It is also important to remember that the IT industry is widely recognised as contributing 3 to 4% of the world's carbon emissions, which is greater than the much maligned airline industry. And to produce cleaner energy, technology advancements continue. Solar, wind, hydro and biomass energy is providing sustainable means to support the world's demands. Solar power currently produces around 1% of the world's electricity needs. However, this technology is still far from ready for mass rollout in light of its costs, as it's very expensive. And as a result of poor energy conversion efficiencies, where only 20% of the energy striking the traditional panels is actually converted into reusable power. Wind power is gaining traction, and it's expected that the energy production via this method will rise quickly in the coming years. While producing no greenhouse gases, the downside is that wind turbines are still found to produce power intermittently owing to wind currents varying. The most successful contributor is hydropower. In Norway, for example, this method already produces 99% of the country's electricity needs, and countries such as Brazil, Canada, and Venezuela are also enjoying success in this field, with much of their needs being met through the use of hydroelectricity. The following detail relates to a real client experience. The development life cycle is chaotic, with diluted lines of responsibility and a number of grey areas. And whilst a certain level of testing life cycle has been adopted for UAT and regression, there is little priority for unit or system testing, which is effectively what the UAT phase in this example finds itself responsible for, with regression test packs being executed shortly afterwards, and in many cases in parallel. Defects found could easily have been avoided using static techniques. Defects found later in the life cycle, as we're all aware, become far more costly. And interestingly, defects found within the code actually generate more energy wastage, and as a result have a direct impact on our environment. Then there is the additional time spent by developers coding fixes and running unit tests to address the underlying problem, producing release notes, migrating code, and then the test teams finally get a chance to retest the defect as well as regression tests the surrounding code. All of which presents a greater impact on the environment, and all of which could easily have been avoided through code reviews, documentation walkthroughs, etc. There is no configuration management process in place, nor even change and release management, and over 100 environments do not share a common build, nor do they accurately reflect production. The resources available in the existing Unix hosts or storage area network are stretched, and in many cases offer little flexibility to upgrade data servers to support additional functionality areas. Furthermore, there is a staff mentality of build it and they will come, add new environments without reviewing what they actually currently have available to them. This model is not scalable to the business and presents a significant environmental impact. Replicating the overnight process utilises approximately 300 CPUs, all running intensively for nearly 16 hours, and this is replicated on a baseline and a build environment across 2 different instances of business areas, totaling approximately 1,200 CPUs. Running this test is often problematic and may need to be run in several times to obtain the correct baseline and build results. And as a result of the points in this slide, projects fail, or at the very least run very inefficiently, presenting a significant impact in financial and global environmental terms. As highlighted by the previous slide, the impact caused by IT systems is significant, and our approach to testing should adapt to be more aware of this. The following is not a definitive nor an exhaustive list. This, however, does give some insight into how we as testers can help with this situation. In many projects, particularly multinational organisations, project staff are located in different locations, either in the same country or even overseas. In many cases, testing personnel travel back and forth for project briefings or update sessions or even knowledge transfer sessions. And going forward, the tester's mentality will need to adapt to consider the impact their travel has on the environment. The current economic climate is helping in this regard, as some organisations are finding that travel costs are more of a luxury item and are pushing employees to adapt their communication methods accordingly. Video conferencing is nothing new. However, this technology is continuously evolving, with companies achieving significant CO2 reductions, whilst also achieving significant cost savings on travel by approximately 20%. Then there's the option to share desktops through various application vendors to facilitate learning and idea sharing. And despite the promise of the paperless office, paper consumption is continuously rising, according to Fujitsu Siemens Global Action Plan and DEFRA. An interesting figure is that over 21 of pages printed are found to be disposed of on the same day that they were actually printed, again presenting a significant environmental concern. And depending on the organisation's policy and risk, or depending on the nature of the organisation's business, the business may be able to incorporate a risk-based testing approach to reduce testing timelines and reduce the redundant or less critical test cases. This should be defined at the organisational level, with tolerances agreed for test management decisions. Test managers should commission sustainable and reusable environments. All infrastructure, after all, is a bookable resource, and as such should be treated in this regard. Test managers should liaise closely with the development community from the initial concept or idea through the information gathering and analysis stages leading to the initial build or prototyping phase, ensuring that all processes are as streamlined as possible to maximise benefits. Some organisations can look at alternative development methods such as RAD or Agile to develop quickly and enter the marketplace with minimal effort, although this is very much dependent on the industry and the internal capability. Again, the testing approach in each scenario differs, and the professional testing skills are required and support. And of course, it's important to be focused, perform impact analysis of change, and then direct your testing resources accordingly. Haphazard testing is no longer acceptable within the organisation. Consumers demand quality products and services and now expect a leaner and greener supplier. So it is important to complete a comprehensive infrastructure requirements gathering exercise, then design and plan accordingly to maximise utilisation of your environments, and share those environments where appropriate with other projects, whether they're related or not. Order work methodically, maximising efficiencies. Structured approaches also help in this regard. Documentation and code reviews should be adopted to understand the quality of the proposed solution early in the life cycle. If defects are found in the documentation analysis phase or through peer group discussions, there is little environmental impact. Likewise, code reviews offer the ability to understand the code in a siloed environment before releasing to complex architectures. They can also help prevent fault multiplication, and producing a fault in an application which triggers faults elsewhere within the application under test becomes far more costly, not only in terms of